Good morning, my dear students. I hope all of you are doing good. I know that online classes are not that effective as the offline classes, but we don't have any other way. So today we will discuss the third chapter of our new textbook, that is Our Changing Earth. In the last chapter, we studied about the structure of the earth, we studied about the three layers, and in this class, we will study about the topic Our Changing Earth. That means the earth, our planet, is changing. Let us see how the earth is changing. So, we will be dividing this chapter into two parts because this chapter is a little bit heavy. I will try to make it simple for you. And in the first part, we will be discussing lithospheric plates. So, today we will be discussing only the first part and we will discuss the second part of the chapter later. So, today we will discuss lithospheric plates. I will be adding some additional knowledge in the class. It will be quite useful for you. So, in the last class, we studied about the crust. Earth has three layers: crust, mantle and core. And in the first chapter, we studied about the lithosphere. What is the lithosphere? Lithosphere is the solid crust of the earth. Earth has three layers. The first layer is the crust, and the solid portion of the crust is called lithosphere. And let us learn about lithospheric plates. What are these lithospheric plates? The lithosphere, no? The lithosphere, the solid crust is divided into many parts. The lithosphere is broken into many plates. That means the lithosphere is broken or divided into many parts. Each of these parts is called a plate, and these plates are called lithospheric plates. So once again, the lithosphere is broken into many plates and these plates are called lithospheric plates. Then these plates are moving. It is due to the movement of magma. What does it mean? I said the lithosphere is divided into many plates known as the lithosphere plates, and these plates are moving from each other. These lithosphere plates are moving from each other. It is due to the movement of magma. Now listen. Think that this is the earth. I will try to make it simple. Think that this is the earth, and these smaller circles, no, these are the lithospheric plates. Okay, these smaller circles are the lithospheric plates. The lithospheric plates are, there are larger and there are smaller lithospheric plates. All the plates are different. Now listen, this is the earth, these are the lithospheric plates. One plate is moving from another. What does it mean? Think that this is the plate A, this is the plate B. Now plate A is here, plate B is here. Maybe after 10 years, plate B comes down and plate B might be here. That means each plate is moving. Plate A may be moving to here, plate B may be moving to here. Each plate is moving. It is due to the movement of magma. So I said lithospheric plates are moving from one another. What is the reason? The reason for the movement of the lithospheric plates is the molten magma. I said in the last class, I said that inside the earth the rocks are molten and the molten rocks are called molten magma. Molten magma means liquid rocks. Inside the earth the rocks are liquid and these liquid rocks are called molten magma. Now listen, the plate's movement is because of the movement of magma. I will give you one example. Have you seen rice boiling? Huh? Have you seen rice boiling? When the rice is boiling, what is happening? When the water becomes hot, it will boil, and if there is rice in it, the rice will be moving. The rice will come from the bottom to the upside. It will be shaking, it will be moving. Like that, this is just an example. Like that, magma is the water, and because of the heat of the molten magma, the plates are also moving from one another. Okay, do you understand? The molten magma causes the plates to move from one another. Then the molten magma moves in a circular manner. Do you know what a circle is? Circle means around. The molten magma means the liquid magma moves in a circular manner. Moves in a round manner. Then the movement of plates causes changes on the Earth's surface. Now listen, I said the Earth has three layers: crust, mantle and core. The solid part of the crust is the lithosphere. The lithosphere is divided into many plates. They are the lithospheric plates, and the plates are moving, and the movement of these plates, the movement of the lithospheric plates causes changes on Earth's surface. The lithosphere plates are moving from one another, and this causes changes on the Earth's surface. That is why the title of the chapter is Our Changing Earth. The lithosphere plates are moving, and because of their movement, there are changes on the Earth's surface. Okay? There are two kinds of forces which causes Earth movements. I said there are movements inside and outside Earth. And what is the reason behind these movements? Listen, if I have to move a table, I have to force. If I have to move a table, I have to force. So what is the reason behind the movement of the table? The force I put is the reason behind the movement of the table. Likewise, the Earth has moments, and there are two kinds of forces which causes Earth movements. These forces are endogenic forces and exogenic forces. Now listen, there are two kinds of forces which causes Earth movements. The first one is endogenic forces. Endogenic forces means ENDO means inside. Endo means inside. So endogenic forces are the forces inside the Earth. And exogenic forces, exo means outside. Exogenic forces are the forces which are outside the Earth. Now listen, endogenic forces causes two kinds of moments. Endogenic forces causes two kinds of moments. The first type of moment is sudden or catastrophic moment. Sudden means fast, quick. So sudden or catastrophic moments are the first type of moments caused by endogenic forces. The examples for sudden or catastrophic moments are earthquake, volcano, landslides. All of you know what an earthquake is. Earthquake is simply the shaking of the earth. Now listen, earthquake is caused by endogenic force because earthquake is happening inside the earth. And earthquake is an example for sudden or catastrophic movement. That means earthquake is fast. It is not slow. It is a sudden or a catastrophic phenomenon. Then the second one, volcano. Don't you know what a volcano is? Volcano means mountains which are spitting off fire. Volcano. Now listen, volcanoes are also caused by endogenic forces. What does it mean? Volcanoes are also caused by forces from inside the earth. Then volcanoes are also examples for sudden or catastrophic moments. Then the third one is landslides. Don't you know what landslide is? Landslide means sliding of the land. If there is very big rainfall or if there is earthquake, there will be landslides. Now listen, landslides are actually on the surface of the earth, but they are also happening from the inside. Their landslides are also happening from inside the earth, and the reason behind them is endogenic forces. That means the forces inside the earth are causing landslides. Then landslides are examples for sudden or catastrophic moments. What does it mean? Landslides are also fast. They are quick. They are not slow. Now the second type of moments caused by endogenic forces are slow moments or diastrophic moments. I said there are fast or catastrophic moments, and also there are slow or diastrophic moments. Example is mountain building. How it is in mountains? Mountains are made very slowly. They are not happening all of a sudden. Mountain building is not a fast or quick procedure. Mountains are built very slowly. So mountain building is an example for slow or diastrophic moment, and mountain building is an example for endogenic force. What does it mean? It is happening from inside the earth. Now let us go to the exogenic forces, meaning they are happening on the surface or outside the earth. Exogenic forces are two: erosion and deposition. Do you know what is erosion and deposition? I will say one example. I took a bucket of water, then I threw it. The water is flowing. So when the water is flowing, soil, small rocks will flow with the water. That is erosion. That is erosion. Sweeping something, if water is flowing, water sweeps the soil, small rocks, grass, everything. That is erosion. Sweeping something is erosion. And after some time, the flow of the water will become slow. The force of the water will be slowing, and after some time the water will stop, and what will happen? The soil and the rocks which the water took will be deposited. The water will stop and the soil and the rocks will also stop. Again listen, I threw a bucket of water, the water is flowing. When the water is flowing, the soil and the rocks are also flowing, and that is erosion. And after some time the water will stop, soil and rocks also will stop. That is deposition. So the two examples the two forces, the two exogenic forces are erosion and deposition. I will say some examples. The first one is river. River is not inside the earth. It is outside the earth. So river is an example for exogenic force, and there is erosion and deposition by the river. The second example is wind. The wind is not inside the earth. It is outside the earth. So wind is an example for exogenic forces. Wind also causes erosion and deposition. When the wind is blowing, soil, sand particles, paper, etc. will blow with the wind. That is erosion. And after some time, the wind will stop, and these things will be dropped, will be deposited there. That is deposition. So wind also erode and deposit. The third one is sea waves. Sea waves are not inside the earth. It is also outside the earth. So sea waves are examples for Exogenic forces. Sea waves also causes erosion and deposition. The fourth one is glaciers. Do you know what glaciers are? Glaciers means frozen mountains or frozen ice, no? Frozen ice. That is glaciers. If we go to Himalayas, we will see ice there. Ice rocks. Frozen ice rocks. They are called glaciers. And these glaciers, when this ice is melting, if there is heat, the ice will melt. And if this ice is melting, the glaciers will also flow like water. And these glaciers are not inside the earth, they are outside the earth. So the glaciers are examples for exogenic forces. And these glaciers also causes erosion and deposition. Why? The glaciers also move. If there is heat, the glaciers will melt and it will move. And with the movement of glaciers, there will be erosion and deposition of particles, of materials. So, these four are the examples for exogenic forces. The exogenic forces are erosion and deposition because they are happening outside the earth. Now let us learn about two natural phenomena. The first one is volcano. Many of you know what volcanoes are. There are volcanoes in the form of mountains and there are volcanoes which are just holes on the earth. And what is the speciality of these mountains and these holes? Through these holes or mountains, through these volcanoes, fire will be coming out. What does it mean? I said inside the earth it is very hot. The rocks will be liquid. These liquid rocks are called magma. And through these volcanoes, magma will be coming out. It will be very hot. Now listen, volcano. It is a vent or hole or opening in the earth's crust through which magma comes out. Did you understand? The second point, it is an endogenic force. What is it? What does it mean? Volcanoes are happening. The source of the volcano is magma. Magma is inside the earth. Magma is coming out through volcanoes. So, the origin is from inside the earth. Origin means starting. The starting is from inside the earth. From inside the earth, magma is coming out. So, the starting is from inside the earth. So, volcano is an endogenic force. Endo means inside the earth. So, volcano is an endogenic force. Then, it is a sudden or catastrophic moment. What does it mean? Sudden means fast. Volcanoes spit out. Volcanoes erupt magma. What does it mean? Magma is coming out from the volcanoes. And it is a sudden or fast or catastrophic procedure or catastrophic moment. It is not slow. Then the next one, when magma erupts, when magma comes out, gases, dust, smoke also comes out. Listen, when magma erupts, gases, dust, smoke also come out. So, if there is a volcanic eruption, magma is not the only particle which come out. Smoke, dust, gases, these things also come out. Earthquake is the second natural phenomenon that we have to study. Earthquake is simply the shaking of the earth. It is an endogenic force. What does it mean? Earthquake is happening inside the earth. The origin or the starting of an earthquake is from inside the earth. So it is an endogenic force. Then it is a sudden or catastrophic moment. What does it mean? It is a sudden or fast moment. Then it is due to the movement of lithospheric plates. Lithospheric plates. In the beginning, I said that the lithosphere is divided into many plates. These plates are called lithospheric plates. I also said that these lithospheric plates move. They move very slowly, and earthquakes are happening because of the movement of these lithospheric plates. Listen. This is lithospheric plate A. This is lithospheric plate B. A is moving to here, B is moving to here. After some time, they will collide. So, these moments are the reason behind earthquake. Listen, we are standing on the surface of the earth. So, we are on the top of the lithosphere, the crust. Inside us, there are many plates. Like the world is divided into many countries. There is India, there is Pakistan, there is USA, etc., etc. The earth is also divided into many plates. We cannot see it, but inside the earth, our earth is divided into many plates. I may be standing on one plate. A person in America may be standing in another plate. And these plates will be colliding. These plates are inside the earth. These plates will be colliding. And what will happen if this is a car, this is also a car, these cars are moving and they hit? What will happen? There will be shock. There will be accident. Likewise, if the plates collide, there will be movement or there will be the effect on the surface of the earth. That is the earthquake. So, earthquake is due to the movement of lithospheric plates. Then the next point is, when the plates move, there will be vibrations on the earth's surface. Listen, I will put you an example. I took a table. Earlier I said I have to push it. I have to pull a table. Now listen, I took a table. I pull it. I kept a ball. And I kept some notebooks. I kept a pen on the desk, on the table. Then I pull it. What will happen? If I pull it, there will be vibration on the table. The book will vibrate. The pen will move. And the board will fall. The board will fall. So, when I pulled the table, there was vibration. The book vibrated. The pen moved and the board fell down. Likewise, if these plates are moving, there will be vibrations on the earth's surface. Listen again. When the plates move, there will be vibrations on the earth's surface. And these vibrations are called earthquakes. Now listen. Everything will have a starting point. Earthquake also has a starting point. This starting point of the earthquake is called focus. The place where it starts, it is inside. Now listen, focus is the point where an earthquake starts. It is inside the earth. Then epicenter, the place on the surface above the focus. So epicenter is not inside the earth. It is on the surface. It is outside the earth. And it is above the focus. Now look at the diagram. I try to make it simple. This point is focus. This point is focus. It is inside earth. And this is the point where an earthquake is starting. Do you see these arrow marks? These are vibrations. I said about vibrations now. These are the vibrations. And these vibrations reach the surface of the earth. These vibrations are called waves. These vibrations reach the surface of the earth. And the point above the focus on the surface of the earth is called epicenter. The point on the surface which is above the focus is called epicenter. Now listen, epicenter is the point which is most dangerous when an earthquake is happening. There will be many destructions near the epicenter, and if we are going far away from the epicenter, the destruction will be reducing. Most destructions will be happening near the epicenter. So listen, focus is the point where an earthquake starts. It is inside the earth. Epicenter is the point above the focus on the surface of the earth. Earthquake waves. The earthquake releases energy. This energy is called the earthquake waves. I said earthquake is happening inside the earth. The point where it starts is the focus. When an earthquake is happening, it will release energy. There will be vibrations. These are called earthquake waves. So, the earthquake releases energy. This energy is called the earthquake waves. These waves reach the surface and these waves causes destruction, causes damage. There are two types of earthquake waves. The first one is body waves and the second one is surface waves. Body waves, they travel through the body of the earth. Surface waves, they are on the surface of the earth. So body waves travel through the body of the earth and surface waves, they are at the surface of the earth. Then body waves travel through the interior of the earth. Surface waves, they don't travel through the interior of the earth. Body waves travel through the interior of the earth. Body waves are from the focus. The earthquakes start at the focus point and the body waves are from the focus point. But the surface waves are not from the focus point, they are near to the epicenter. Focus is inside the earth, near the focus there are body waves, epicenter is on the surface of the earth and near the epicenter there are the surface waves. There are two types of body waves. The first one is P waves or primary waves or longitudinal waves. The second one is S waves or secondary waves or transverse waves. So the two types of body waves are P waves and S waves. Then there are two types of surface waves also. The first one is L waves or love waves. The second one is R waves or Rayleigh waves. L waves and R waves. These are the two types of surface waves. The notes given in the textbook is little different from this. There is additional knowledge in the note that I have given. It is written in the textbook that you have to collect extra knowledge by yourself, but I gave you these notes. Study it. We can't stop earthquakes, but we can reduce the damage. We can never stop earthquakes, but we can reduce the damage if we are prepared. By studying animal behavior, we can predict earthquakes. Listen, earthquakes can never be predicted. We cannot predict earthquakes. We cannot predict when earthquakes will happen, but by studying animal behavior, we can predict earthquakes to a certain extent. It may not be perfect, but to a certain extent, we can predict earthquakes by studying animal behavior. For example, if we study the behavior of fish in the ponds, or if we study the behavior of snakes, we can predict earthquakes. The people who lived in the past times did so. Then earthquake is measured using seismograph. Its strength is measured using Richter scale. We measure everything now. My height is measured in centimeters or inches. My weight is measured in kilograms or pounds. Likewise, earthquake is also measured. Earthquake is measured using seismograph. Seismograph is the machine by which the earthquake is measured. Then its strength is measured using Richter scale. The strength of the earthquake is measured using Richter scale. Richter scale has a range from 1 to 10. If the Richter scale mark of an earthquake is above 6 or above 7, that means the earthquake is very dangerous. But if the mark for an earthquake is just 1 point in a Richter scale, that means that the earthquake was not that dangerous. I know that there are many difficult terms in this chapter. You have to study all these terms. There is no other way. I have tried my best to make it simple. Anyway, we will be covering the second part of this chapter in the next class. So all of you read the textbook, study well, be safe at home. Bye.